Blender for Noobs.
Hello, this is Dan Nobles and welcome to Blender for Noobs and welcome to this tutorial on 3D printing. Now I've broken up this tutorial into two parts. The first part is basically just going on about how you create a model and get a model ready for 3D printing. And part two is going to be actually submitting your model to a 3D printing service for anybody who's interested in that part of it. Okay, so Blender and 3D printing. This is something I've recently got into because I thought, 3D printing, you have to have a 3D printer and you have to make sure your model's, perfect and everything in order for it to print out, and it's complicated and blah, blah, blah. Well, I recently got into an opportunity to learn how to 3D print, create models for 3D printing and things like that. And I found out that it's not so bad. Once you know a few key elements and things to watch out for, you can be 3D printing in no time. And how can you print something without a 3D printer? Well, there's just tons of services that have cropped up that you can send your file to, send your blend file, and, well, not your blend file, but your uploaded export file to them and get it 3D printed and sent to your mailbox. So pretty cool. So how do you do this in Blender? Well, I got this very simple model here that I created as a sample that we're going to work with. So let's say we want to get this 3D printed. Okay, so the first thing we need to do is, since we are making an actual real world object that you're going to be able to hold in your hands, we need to make sure that we're working in real world measurements in Blender. Now I have a little tutorial that I did just a while ago on getting real world measurements, but basically what we need to do is come over to our scene settings and you want to look at your units. Now you can use metric or imperial, but for the service that I'm going to be showing you, I found that I can use metric. I can kind of make it work, but I've found recently that if I use just none, which is sticking to Blender units only, it turned out that it seemed to work a lot easier for me. So I'm just going to use the regular, and this is by default none, and that's Blender units. So if we choose our N key to bring up this tool, this shelf here, these properties, what we're looking at is dimensions. So right now, basically what we have is 11 by 11 by 2 for the height. So what I would like you guys to do when you're looking at these dimensions is think in terms, even though these are Blender units, think in terms of either inches or millimeters. So in other words, if you're going to use inches, it'd be 11.506 inches or 11.506 millimeters. So what I'm going to do, I'm going to use millimeters. So if I think 11 millimeters, it's really only like 1 centimeter, right? So I would have to actually scale this up quite a bit. So scale this up. So I want this thing about, I don't know, about 4 inches long, and 4 inches in millimeters is about a little over 100 millimeters. So I'm just going to scale it all the way up. Oops, too far. To about 100 right there. So, okay, so now it's kind of the size that I want generally. But what we need to make sure of is see how when I scaled this up, it's really just screwed up the scaling right here. It should be 1 to 1 to 1. So in order to fix that, just do a Control A and go to Apply Scale, and that'll bring it back to 1. This is very, very important. If you don't do this, it will not keep the correct dimensions. Okay, so we got our dimensions right. What else do we need to do to this model in order for it to work? Well, let me show you a little trick in Blender, or not a trick, but some tools that we have. So I'm going to choose N to get rid of this. I'm going to go ahead and do a quick save on this thing. Okay, File, User Preferences, and I'm going to go to Add-ons. And we have a 3D printing toolkit. So if you go in here and you just type in the search bar 3D, then you will see this Mesh 3D Print Toolbox. Very nice little toolbox here that is included in Blender. So we're going to turn it on, close this, and then we're going to choose T for Tools. And when you do that, you will see this 3D Printing tab magically appear. So we're going to choose that and come down here. And if you go into your model, tab in your model, we can kind of see how this looks. And we have this little button called Check All, okay? And if I'm in object mode and I do a check all, it's going to check everything, but you're not going to see any of this output here highlighted. It's just going to, be nothing. So what you need to do is tab into object mode, and then you will start to see some things show up. Now, unfortunately, I only have one thing showing up here. It's unfortunate because I want to kind of show you some problems, but I don't have too many problems with this. But you can see we have this overhanging faces. It says we have 60 of them. So you can click on your problem here and it will actually highlight what you have. Now, okay, the reason that it's finding these overhanging faces is because it's looking at the bottom of, these faces on the bottom of this, and it knows that there's stuff on the top that the printer has to print. So it's thinking, well, how is the 3D printer going to print this stuff on the top if we got, this stuff on the bottom that's going to be, it's going to have to get down there and print it somehow. Some 3D printers, I guess in the past, or maybe some currently, cannot handle that. So here's what I'm going to suggest for this output. It's kind of, I guess you could say it's kind of overkill, because they try to find all the different problems that could be going wrong when you send your file off to be 3D printed. So, some printers, depending on what kind of printer you're using, may not be as gracefully forgiving on some of these as some others. So I have found in my experience that, at least working with the service that I tried to print something out with, I don't have very many problems with any of this at all. The one, few things that I'd like you to concentrate on is the non-manifold edge. This is very important because if you have like an edge, I don't know, maybe I can create one here for you real quick just to show you what it might look like. Extrude, extrude that edge. Okay. So let's run the check again. Check all. And tab in object mode. Oh, look at there. I got 4 non-manifold edges. Then I click on that and bam, it tells me exactly where they're at. So this is kind of an example. This is very poor practice to do something like this. So a lot of times you'll find something like this in your model and it won't be so apparent. And, especially if you got a complicated model, you'll end up creating non-manifold edges and not even know it sometimes. So it's just, a good idea that actually I can get rid of that full loop. It's a good idea that, you can do this and check it out. Now, if you weren't 3D printing and you wanted to find those problems anyway, you can come down to select and you can go to select all by trait and you can choose non-manifold here. You can find different things on your model that might need to be fixed. Okay, so back to T Tools menu. Okay, so pay attention to your non-manifold edges. Bad contiguation, or I guess it's contiguation, I'm not sure. I haven't had any problem with these edges here. Intersecting faces, that can be a problem. Keep that in mind. Zero faces, not so much. This has to do with your scale. Make sure you've scaled your model 1 to 1 to 1 like I showed you. Make sure that it's not too extremely small. Zero edges, I haven't really had a problem with that. Non-flat faces, keep an eye on that. That would be like, oh boy, if I went into the model, let me select faces. And let's do vertices. Let's say that I took this, went over there, and I needed something like that. I've just created a non-flat face because within this face, turn this on, turn faces on. Within this face right here, I mean, you can tell, hopefully, that it's really warped. Bad practice, of course, but it will detect things like that. And I guess, a lot of 3D printers, if they see something like that, they're going to go, what the heck is that? I don't want that. Leave me alone. So I'm going to go Control Z, put that back, but that is what they call non-flat faces. So keep an eye on those. Thin faces, I don't really think I've run into any problem with thin faces. But it's good to know, if this comes up, sharp edges. I haven't really ran into a problem with that. Overhang faces, like I said, yeah, they're there, but it's because of the printer I'm sending it to, it's not going to have a problem with that. It'll just say, okay, I'll print it. So don't panic. Just the ones I was pointing out, like non-manifold, intersect face, and non-flat faces. And then, of course, if if it doesn't pass the tests when you go to try to print it, then you can look at the other ones and say, well, okay, it doesn't like that, so I need to do something. Okay, so we've done this check on it. Is there anything else that we need to do here? What did I do there? Oh, it's a camera. I'm like, what the heck is that sticking out of my plane? It's not good. Okay, anyway. So I have this plane. Okay, so here's the deal with 3D printing. You can say, okay, I want this plane, and I can send it off. And right now, if I send it off, I'm pretty confident that it will probably pass inspection, and they'll say, okay, we'll print it. But there is something you need to look at. So if we choose in on our properties here, and we look at our dimensions, okay, I know that this is, I'm thinking this as 100 millimeters by 103 millimeter, or 103 millimeters by 100 millimeters. And that's how big I want it to be. So if I go and I upload this and I go to have it 3D printed, I don't know, it may cost me $12 or maybe $20. I don't know. But if it costs too much, you may have something small and it only costs like $5 and you're okay with it. And you say, okay, go ahead and print it. But say I have this, 4x4 inch model, and I say, it's $20. And I think, well, it's just a small model. I just want to test it out. I really don't want to pay that much for it. Or let's say that you got this really cool little design that you've created, and you want to kind of mass produce them. Say, you can print in things like gold and silver and platinum if you're rich, and you can print this stuff out and make really cool things. And you can make parts. You can sit here, if you know how to use Blender, you can design a part that broke on your washing machine or something and say, oh, I can fix that. I'll just design a part. So you design the part, you get it printed, and hey, I just made my own part. So you can do that. Or like I say, if you're going to try to make a bunch of something, then you want to do it as cheaply as possible. 3D printing is fairly expensive, unfortunately. So hopefully, as the technology matures, the prices will come down, I'm sure, I hope. But there is something that you can do to help out the price. And that is, brings me to another point. When you create your model, you need to look at it and say, and ask yourself, is it watertight? What does that mean? Well, imagine if this is a real plane, and you put it under the water. Is it going to sink, or is it going to float? So basically what I'm saying, is there any holes in it? Did you come in here and do this X face, and you can't really see it very well because it's subsurfed, but did you make like windows and they're open? If you did, no, that's not going to work. Everything needs to be closed up. So that's why I say with this particular model, I think I can go ahead and send it off and it should print out fine. But what we do to save money is we actually do put a hole in it. It's called an escape hole. And what the escape hole does is it allows, when it prints the plane, it'll allow all the excess material, instead of making it solid inside, it'll allow that material to fall out of that escape hole, and you won't pay for that excess material. Very cool. So you need to find somewhere, if you want to make this cheaper, you need to find somewhere inconspicuous on your model that you want to put your escape hole. So I'm just going to say, for the sake of our argument, I'm going to put it right here and come in here and extrude, scale in, and I'm going to say right there. That's my escape hole. X faces, delete. There's my escape hole. Now, something very important about the escape hole, you need to look at, if you have a 3D printer, you'll have to look at, your specifications, or if you're sending it off to a service to be 3D printed, you'll need to look at what their specifications are as far as the size of this escape hole. It's got to be a minimum size. So usually it's not a big deal. I mean, I just make an escape hole, and I know that it's, it can't be, you don't want it too big. I mean, you can make it bigger if you want to, but you don't want to make it extremely small. So something like this size hopefully will work. So what you have now is you have this escape hole, but you cannot print the model out like this, if we just send it off like this, because these faces, all these faces that make up your model, are infinitely, infinitely thin. They do not exist in the real world. They only exist in the 3D modeling world. They have no width to them at all. So how is a 3D printer going to print that? They cannot, because they don't have any width. They say, well, there is no model there. So in order for this to work, what you need to do is you need to put inner walls within your model, and then connect it up with this escape hole, so that basically what you're doing is you're making this kind of hollow out area in your model. And I'll show you what I mean. Now, there is two ways to do this. One can be a very easy way if you have a simple model. Let me get rid of this. And that is, we can tab into object mode, come over to our modifiers, and add a modifier, and use the nice solidify modifier. Bam! I just added solidification to the model. So you can see it has some problems here. But what you do is you go over to your properties on this solidify modifier, and you want to look at the thickness. This is another point where you need to know the specifications of the 3D printer, how thick this needs to be at a minimum. And I know that it needs to be 0.7 millimeters in thickness, at least. So if I convert that over to inches, it's like 0.02, but I'm working in millimeters, so I want this to be at least 0.7. Okay, and I'm thinking, I'm right on the border there, so, just to be safe, 0.75 or something. Okay, you'll notice when I did that, we have some thickness there. So now the 3D printer can see some thickness there and says, oh, okay, I see something of substance there, and I can print it out for you. And I'll just print out the shell, and I'll let all the excess material fall out that hole. Very cool. Okay, one thing you want to make sure that you do is come over here. By default, I think it's set to fill rim. for this. If it wasn't, and you can see that this is open, but you want to make sure that, yes, wherever you have a rim there, it is closed. In some cases, depending on what you're printing, you may have 2 escape holes. In fact, they may require you to have 2 escape holes, so keep that in mind. Okay, so this is all well and good, but we have a little problem. If we look at our tail fin over here, see how something's not quite right? Well, this is so thin that the solidify is actually, it's coming outside the model, so that's not good. It will not pass inspection at all. It'll say that you have thin walls, which means that, this thickness here is really too thin. It's not, except when it gets to this very thin tail fin. So how do you fix that? Well, when I first started looking at this, I thought, when I had to create the interior of this, I thought, oh man, especially because I was working on like a human figure, I thought I'm going to have to somehow get the solidify modifier to go into every nook and cranny and get it just right so that, it's the correct distance away. And that's very stressful to think things like that. It turns out it's not that hard, not quite that hard. So in this case, because we had this very thin tail fin, we would say, well, we may not use the solidify modifier. The solidify modifier definitely can come into play if you have, a thick model and, it's fairly simple and it'll work. You can try it. You'll get to where, you're used to, whether it'll work or not. But I'm going to show you a different way to do this. So I'm going to kill this solidify modifier, and we're back to this. Now this is the second option to hollow out your model. So here's what we're going to do. Tab into edit mode. We go into vertex view, and I'm just going to alt select these. So now what I'm going to do is I'm just going to create my own solidify basically. So 3 side view, actually let's go control up arrow so I can see what I'm doing. Z, wireframe view. So E, extrude, come up here. Now what you got to watch out for is you have to kind of know, maybe you want to measure out first what, come over here, use your T menu and go to, I think it's, where's the grease pencil? Grease pencil, ruler protractor, and you can measure, your distance here. So in this case, as long as we're over 0.7, then we should be far enough away from the wall. In fact, I could back up a little bit, but that's okay. So at this point, I'm just going to, what am I going to do? I guess I'll do extrude, go all the way up here and kind of look at where it's at according to the walls. You can get very precise with this, or you can get, just stay far away from the walls and do it more quickly, I guess. So I'm not going to spend a lot of time on this, but I just want to show you basically what you can do here. So Control R, I'm going to throw an edge loop in here. So that way I can choose this face, extrude, and bring this out this way. Okay, so this is, this is very quick and dirty here, but just to give you an idea. So extrude, and I can bring this all the way up here. And of course it's going to be sticking out, so just scale that down. So basically what I'm doing is making a very rough hollow out. I'm not being very detailed at all because I'm more, I'm worried about saving a little bit of money instead of, spending a lot of time on this. Come out back here, bring that down, maybe move it over a little bit, keep it out of the way. Okay, so if you got room in your wings as well, you can extrude out to there. The idea is that all this inside area needs to be, that you're creating needs to be hollow. So if I go into Z and look in here, up there, all that needs to be hollow that it's going into. So okay, what did I do here? Did I have an opening? I definitely had an opening. Wow. Okay, close that up. And that's what I'm talking about. It's got to be, closed in there so you have some thickness. Now, I have way too much thickness in this. I'm just creating this little hollowed out area. So especially if you're going to be printing out a lot of things, or if you want to save a lot more money, you want to take time and get it, as close as you can to the walls there, so you can, kind of maximize your savings is what I'm trying to say. Okay, now I'm going to show you a little trick, because what will happen, especially when you first start trying to print something, is you'll send it off and it will fail, and 9 times out of 10 it'll fail because it'll say your walls are too thin, and you'll go, what are you talking about? My walls are too thin. I'm far away from the wall. Well, inevitably when you're doing this, you'll run close to a wall and you won't even realize it. So here's a little trick you can do to kind of speed up the workings of this and detect it a little bit. Tab into edit mode, go into vertex view, and I'm just going to let me alt select this edge loop right here, and I'm just going to choose V to disconnect those verts. Basically what I've done, just because this is the one thing holding that interior hollow out piece to the rest of the model, I just disconnected those both. So what I can do is, if I can see something up here, I can select it, and I can do an L select and go into Z wireframe, and I'm able to select only the hollowed out piece, which is nice, because then I can see, maybe over here I went too close to the wall, and okay, I need to fix that, or, look at it this way. And it's very, a lot easier to compare it to your exterior of your model this way and work with it. Okay, so once you've determined what the problem is and you fix it, then you can come back and Z back into your solid view here. And in order to fix these verts, all you need to do is select everything, select everything, and do a W and remove doubles. Removed 4 vertices. So as long as these vertices are on, directly sitting on each other, it will see them as doubles, and it just welded them back together. Very cool. Okay, so, and that's also a good trick to know in your normal modeling as well. Okay, so I've created a model. I've created a hollowed out. I made sure that, my scale is 1 to 1 to 1. I made sure my dimensions are okay. The next thing I need to do is I need to make sure that I export it correctly. So what I recommend to you, because if we go to control up arrow, we go back here, we look at our modifiers. If you don't have any modifiers sitting here, then, we could go ahead and export it. But since I have a subsurface here, and I could just go ahead and apply this if I wanted to, but I want to keep my subsurface intact in case I want to change it later. So what I'm going to do, Control S, quick save this, do a file save as, and I'm just going to call this for export. Okay. And that gives me a kind of a working file, so I don't destroy my original. Once you have this working file, you want to apply all your modifiers, and now we can export. So I'm going to choose File, Export, And you'll see this STL format. That's the format that is most commonly used to export 3D printing, and it's definitely what I'm going to use to send to the service I'm going to use. So I'm going to choose that. And then we have our options here. Now this does have the apply modifiers. So, I probably could have used my other file. I haven't had any problem doing that, but it's just good practice to have like a working file so you don't screw up your original work. Okay, and I normally change it to scene unit. So it's kind of, if I set it to, say if I set it to metric, then it will read as metric. I've done that okay. But like I said, I've had better luck just using my regular Blender units, at least with the service that I'm sending it to, and then converting it from there. But I'll show you that in the next part of the tutorial, how that's done. But anyway, so you want to choose scene unit, apply modifiers, apply modifiers, and then, so I'm just going to save it as the STL file. So export STL, we got our file, and we're ready to go off to the 3D printing service and see if our model passes their rigorous inspection. So, hope you enjoyed this. I'll see you in part 2 of 3D printing in Blender.